All right, let's get started creating a MyRio project. I'm going to create this project with the name Web Services. And I'm going to place this in the folder called C Demo. My device is already plugged in, so I can see it right here. Try clicking the refresh button if you can't find yours. I'll go ahead and click Finish now that my device is selected. I won't be needing this file for the project, so I'll go ahead and delete that. Select the target and then create a new web service. Select this web service and then rename it API. Select Web Resources and then choose New Web Resource. All right, I want to rename this to External, and I've pressed F2 in order to rename it. This web resource will be for the external webcam. This web resource will return its results in the form of a JSON string. This web resource will return information about the onboard devices such as the accelerometer and the onboard pushbutton. This web resource will return information about the system such as the date and time. And finally, this web resource will return the same information about the onboard devices, but now in the form of a JSON string. All right, let's begin by creating the method VI for the date. Select System and then New VI. Press Ctrl E, choose the timing subpalette, and then select the Get Date and Time function. Here's the date string output. Let's create an indicator for that and then rename it to Date. Let's go back to the front panel and connect the indicator to the terminal frame of the icon. Let's go ahead and save this VI. I'm pressing Ctrl S. It will be saved under the demo folder and it needs to be called Date. All right, let's check the Explorer window. Right-click on API and choose Properties. Choose HTTP Method VI Settings. Select the Date VI, the Output Type tab. We'll keep the default setting as Terminal, and then choose Text as the output format. All right, let's give this a try. Choose the API web service, and then choose Start to run it on the debug server. This process requires just a few seconds of wait time. The pop-up says the web service is now running and we can connect on port 8001. Right-click on the method VI to get its URL. Let's study this URL for a moment. There's the IP address of my connected device. The debug server is port 8001. API is the name of the web service we created. System is the name of the web service we created. And finally, Date is the name of the method VI right here. Let's go ahead and copy the URL to the clipboard. Then I'll open up Internet Explorer and paste in the URL. using Control V for the paste operation. And the web service responds with the string date equals and then the system date. Now looking back at the construction of the VI, we see that date was the name of the indicator, and then the value of the indicator was the system date. Now this is a pretty simple technique to get up and running. However, you don't have a lot of control over the string that's returned, at least using the terminal method. All right, let's move on to creating the method VI for the system time. Select System and then New VI, but it's not available because the debug server is still running. So we'll go ahead and stop the debug server. All right, let's try this again. We'll go ahead and do a save on this one. Type Control S, and then give this the name time. Type Control E to get back to the block diagram. We'll use the same technique as we did earlier. This time I do want seconds, and we'll create a constant for that and set its value equal to true. Take the time string output and create an indicator for it named time. Now this time we need to do things a little bit differently, and we'll be making use of this front panel control, and let me point that out to you again. It's automatically included when you first create the method VI, and it's already attached as an input terminal. Now look under Connectivity, Web Services, and then Output, and let's go ahead and pin that subpalette. I need two functions from the subpalette. The first one is write response. I'll place that one over here towards the end. The write response function needs the LabVIEW web service request, and we could connect that directly. However, I'll use the second function, set HTTP response MIME type, and insert that in the middle. We'll use this function to set the type of information that's being returned by the web service. We'll go ahead and connect the same web service request through from the original function through the set HTTP response MIME type and then to the write response. The response is the response string, which is simply the time. Now we could leave the indicator on the front panel, but it's not actually required. I'm going to go ahead and delete that and just make a direct connection. Let's do a wire cleanup on that one. All right, now this time string is the primary output of this web service, and we need to be a little more specific about the MIME type that's returned, so that way the string is interpreted properly. By default, you see that the web service would be returning HTML code, and we need to create a constant here, so that way we can select just plain text. All right, I'm doing a Control S to save the method VI, and then bouncing back to the Project Explorer window. Choose API Properties, Method Settings, choose Time, and then the output type is now Stream. We will stick with the defaults, and now let's give this a try. Let's grab the method URL, going back to Internet Explorer and pasting in the URL, and you'll notice this time that the method VI simply returns the plain text string with no embellishment. All right, let's start working on setting up the onboard push button. We'll need to stop the debug server. Click onboard and select a new VI. We won't be needing that. Let's drop down to the MyRio palette and look for the onboard push button Express VI. In this method VI, we'll be using the terminal method again. So I will need to create an indicator for the Express VI, and we'll create that indicator and rename it button state. We'll do Control S to save the VI, and this one is known as push button. Let's go back to the front panel, and I'll move this indicator to the right spot, and then set up the connection to the icon's terminal frame. Let's be sure to save that one away, and then go to API properties. Select the push button output type, and we want terminal this time, and then select HTML. And let's restart the debug server. Let's get the method URL copied to the clipboard. Go back to the browser and use Control V. And we see nicely formatted HTML table, and the button value presently is 0. I'm going to try holding the button down now and hit refresh. We see that it's 1. I'll let go of the button and do refresh again, and we see it's back to 0. Let's close this down and stop the debug server. All right, now let's create a web service that returns a JSON string, and this will be also an onboard device, this time for the accelerometer. Let's go ahead and save this right away and give it the name accelerometer. Do Control E to get back to the block diagram. We'll come down here to MyRio and then find the Express VI for the accelerometer. Make sure that all 3 axes are enabled. I'll show you 2 different ways to return the JSON string. The first one as an array of 3 values. Begin by building an array from these 3 values. Let's create an indicator for that and call it the accelerometer array style version. The second method I'd like to show you is how to return values as a cluster of named values. For this, we will be using bundle by name. We will need 3 inputs for this. We need to create a cluster constant. Choose create constant. And then into this constant, I will drop in 3 numeric values. Right-click and choose auto sizing is none. Let's make this a little easier to work with. Right-click and choose visible item label, and this will become the X value of the accelerometer. Do Control Shift and then drag to copy the value and then rename it Y. And do that one more time. That is Control, Shift, and drag for the Z value. Now down here we choose X and then Y and then Z. If you like, you can double click the frame to minimize it and then double click it again to restore it. Let's get the accelerometer wired up to the bundle by name. And let's create an indicator right here, and we'll call this the accelerometer, but now with the cluster technique. Bounce back to the front panel. Connect the cluster first and then the array second. Do Control S to save our work. Select API and then Properties. Select the accelerometer method VI, and then the output type is JSON string. And let's go ahead and run this on the debug server and see how it works. Looks good so far. Let's go ahead and get the method VI URL. We'll paste that back into the browser. Browser reports the web service is returning 89 bytes. Let's go ahead and open that result. And the browser opens the JSON string in my default text reader. We see accelerometer as an array, followed by colon, and then the 3 values in square brackets, and then accelerometer as a cluster, colon, and then we see the 3 values where we have the name of each of the 3 parameters, X, Y, and Z as well. All right, let's create the method VI for the onboard LEDs. We'll hit Control S to save the VI, call this LEDs, and let's start working on the functionality for this VI. I'm going to build this essentially in reverse order, so I'll begin with the express VI that drives the onboard LEDs. We'll need to enable all 4 LEDs. I need to drive these 4 LEDs from a single numerical value that ranges from 0 to 9 and then A to F. We'll use this function called hexadecimal string to number. We'll create a control called state, and this will be part of the query string in the URL. And this function converts the character in that string to its numerical equivalent. Under the Boolean palette, we need the number to Boolean array converter. And from there, we can use the index array to pull off the individual bits of that 4-bit value. You can pull that lower handle down, exposing 4 outputs. Now I'd like the web service to echo back the full 4-bit LED state, and we'll be using format into string. We'll take the numerical value and represent this in 4-bit binary representation. Use the format B for binary, 4 for 4 bits, and then I would like to have 0 padding on the left side, so we'll use %04B. And then create the indicator LED state. Let's save that and then bounce back to the front panel. The state control needs to be connected as an input to the icon, and this will make it part of the query string. And then LED state is a return value, so we connect that to the output. Let's go ahead and save the VI. Let's make sure we have the proper settings for this method VI. Choose the LEDs VI, and the URL mapping is get, and you can keep the defaults. And the output type is simple text. Now let's see how this looks on the debug server. It says API on board, and then LEDs, question mark, begins the query string, and then state equals some value between 0 to 9 and A to F. Let's first try the value 1. Look at the onboard LEDs on your device, and you should see that LED 0 is active right now. And that would correspond to a 1 in the string right here. Now let's try another value. Let's try to get a little more room here so you can see the entire URL string. I'll enter 8. Press enter, and now you should see that LED 3 is active. F should activate all 4 LEDs. And again, check the onboard LEDs for your device, and you should see the pattern matching what you see here on the browser screen. All right, let's start work on the webcam method VI. Hit Control S and type in webcam for the name. And I already have my webcam attached to the device USB port. Let's get started with vision and motion, and then vision express, and vision acquisition. Now look under NI, iMac, DX devices for your webcam. And this is my particular webcam. Try clicking the refresh button in case you don't see one attached for your own setup. Click the play button and confirm that you see something. I presently have my webcam pointed at my printer on the desk. I'll wave my pen in front of the camera and confirm that we are seeing a stream of live images. Go ahead and click Next, and we are doing single acquisition with processing, and make sure this option is selected. If you like, you can adjust the video mode, and you can see all of the available modes for your particular camera. I'll just go with the default of 640 by 480. I'm not doing anything with image logging, so we're done. Go ahead and click Finish. At this point we have a reference to the image, and you could look at this on the front panel as an indicator if you like, but I'll just go ahead and delete that at this point. Now that we have an image available, go to Connectivity and look under Web Services, Output, and choose Write Response. And then we need to set the MIME type for an image. Go ahead and create a constant. And then scroll down through the list until you find image/JPEG. The way we get from a reference to an image to a string is located right here. We'll look under Vision and Motion, and I'll pin down this palette because we'll be using it for a little bit. Look under Vision, Utilities, Files, and then iMac Write String. This is a polymorphic VI, and we'll select the JPEG version. This function accepts a reference to the image, so it's not the image data itself, but rather a pointer to the image in memory, and then it formats that into a string, which we then deliver as the output from this method VI. Eventually it will be useful to get the flush output function established, so I'll go ahead and place that now. Alright, I'm going to take a quick time out to link the web service request to all three of these VIs. Alright, doing a Control Save or a Control S, and coming back to the Project Explorer window, we'll choose API and then Properties. And for our webcam method VI, we want the output type to be stream because we are using our own custom output that is the image output. And I've got the webcam attached at this point. Let's get the URL for this method VI. And I'll paste it into the browser, and let's see if we get an image. Yes, we do. Let's give this window a little bit more space so we can see the image more clearly. This is the 640 by 480 image. I'll hold my pen in front of the webcam and hit refresh. And I'll take the pen away and hit refresh again. Looks good. Each time you refresh the browser, that invokes the web service again and it captures a new image. Well, let's improve the webcam method VI so that it accepts the desired resolution of the image. That is, we can specify the X dimension and the Y dimension from a query string as part of the URL. We'll use this function, read form data. We'll do this for both the X dimension of the image and the Y dimension of the image. Let me get both of these inserted into the wire for the web service request. The first key value, as it's called, is X. This will be the value that appears in the URL query string, and the second one is Y. So X being the horizontal dimension and Y being the vertical dimension. Let's move both of these up a bit. These two functions extract the values from the query string, and these are numbers, but they're still in the form of strings. And so we'll need this conversion from string to number. This function, decimal string to number, will take in this string representation of a numerical value right here, and then return it as an integer right here. We'll need to specify a default value for the case that the value is not specified as part of the query string in the URL. I think I'll go ahead and use 640 as the default in case it's not specified. And we'll do the same thing for the Y value, set that up as a default of 480. We won't be needing this subpalette for a little bit. Let me just scoot that out of the way. Let's look under Image Manipulation and then iMac Resample. This function will accept an image reference and then resize it accordingly. iMac Resample will require a reference to the source image, and it also needs a reference to the image destination into which the resampled image will be created. We'll look under Image Management, and then here's iMac Create. Place that here temporarily. We'll get back to that in a minute. And I also want to take care of freeing up image buffer memory that's created. And so we'll use iMac Dispose for that purpose. We need a name for this image buffer. I'll call it IM0. The actual name doesn't really matter too much, at least in this application. The image type is RGB for color. It produces an image reference to the buffer that we connect right here. We'll connect this reference to the resampled image to the output. That's what we'll be returning back from the web service. And lastly, we'll take that image reference and free up the buffer memory that was associated with it. And while we're at it, let's use the true constant to free up all image memory that was allocated by the VI. Resample has an input called interpolation type, and here you can choose whether or not you'd like to do a CPU efficient method that's not very good, might be kind of blocky artifacts, or you can do a smoother interpolation but requiring just a little bit more CPU effort. And finally, we have the X resolution and the Y resolution. The desired X resolution is right here, and the desired Y resolution is right here. Let's save the VI and then start running it on the debug server. Let's grab the URL for this method VI. We'll paste that into the browser. And there's the full-size image. Let's try changing the X size. I'll append question mark X equals 100. So we'll shrink this up a bit and then hit enter. And we see that we still have the default height of 480 pixels, but now the horizontal dimension has been shrunk down to 100 pixels. Let's try this with the Y value. We'll connect the two using an ampersand and then say Y equals 200 and then hit enter. And let's also try making this a square image, 200 by 200. And let's try this one more time that the refreshing work. I'll hold my pen in the way and hit refresh, and then take it away and hit refresh again. Looks good. All right, I'm going to add one final improvement to this method VI. We're going to add the refresh field to the HTTP header, and this will cause the browser to automatically refresh itself, and that will cause the web service to run automatically every so often. We'll need this function called setHeader. This function requires a string to specify the desired header field, and that's going to be refresh. And then we need a string for the value, and I'll use 5 for 5 seconds. I'd like to get this little piece of code dropped in between the set HTTP response MIME type and write response. I'm going to insert some space by holding down the control button and then doing a left mouse click and then dragging to the right. And I'll take a quick time out here to just move that down, and that looks good. Let's go ahead and save these changes and then restart the debug server. Let me grab the method URL one more time and then paste that into the browser. Now take a look at this area right here, and I'm not touching the refresh, but you can see it automatically presses itself, so to speak, once every 5 seconds. And I'll demonstrate this using the pen technique again. Now that we've finished developing and debugging the web service, it's time to publish it. Right-click on the web service as before, but now instead of choosing Start, choose Application Web Server and then Publish. Notice that there's also an option to unpublish a published web service. We'll select the Publish option, and from this point it looks very much like it has in the past in terms of compiling and so forth. The only difference now is that these compiled files are also being deployed on the device, and this can take a bit of time. Pause the video here for a second and hop over that part. I'll pick one of these method VIs, the system time, and then show method URL. Available servers are listed right here, and we are particularly interested in the application server, which is port 8080. Copy this URL and then paste that into the browser. And of course, this is familiar behavior, but now recognize that the web service is actually running on the device itself. One last thing, let me show you how to get the method VI URLs in a single display. Right-click on the web service, choose Properties, and then choose Sitemap. And there you see all of the method VIs that have been created and their associated URLs.